Now let's look at this NUMA organization. It's NUMA, and it's basically, it has couple of types, shared machine types we start with. Uh, One is this uniform memory access, okay. Another is non-uniform memory access, which is NUMA, which is in our study, and there is a cache coherent NUMA or CC NUMA, which we'll just leave aside for this class. Basically, if you are interested, you can actually read up extra for these CC NUMA type of machines. So uniform memory access is what is happening in the cluster memory, which is basically your your, as I said, like your parallel programs, parallel threads, or parallel sub processes can enjoy memories that is located within the machines where it is being running. Okay, so it is kind of node bound. If a node has maximum of, let's say, 256 gigabyte of memory, then your sub process is limited to that 256 memory. If anything beyond that data, like it need beyond that data, then it need to, your application program need to do something special of transacting like content or information over network from another node and stuff like that. So your program has to be aware of those problems. Now that problem is solved in NUMA architecture. So let's say there are 4 machines which has, each of them has multiple processors, and these processors maybe have multiple cores in it, or think of in a way like multi-core processor with multiple core inside it, whatever way. They are kind of equivalent nowadays. Either your processor goes on the board or whole system is on one chip. It doesn't matter. The idea is this has like 4 system as an example. So you can expand that into more. You just keep on adding machines to the network as in the cluster system. So each of this node has memory, right? Main memory. Let's say each of them has 256 gigabyte of memory. So in the cluster architecture, what happened is that your parallel threads or parallel sub processes are bound to those main memory of the system, which is available locally, which is maximum, let's say 256 in this scenario. But you see, your entire system, even with the four computing nodes, has like 1 terabyte of memory, right? So what if like we develop a system which basically can share the memory over the network? That's the concept in the NUMA. Okay, the NUMA, from a process point of view, wherever you are running, it doesn't matter, you are seeing a big 1 terabyte space. Okay, if you, of course, assuming you asked for that kind of system to the cluster middleware, and you can access them, the entire 1 terabyte, as if it is attached to locally to your machine. Okay, so what happens, like these operating systems are aware that it's a NUMA architecture and your memory space can be more than what your main memory has in the system. So your address, if a process, your sub-process thread is asking for an address which is beyond the main memory, it asks or request for that address content over the network, and corresponding machine which has that fragment of memory serve that data back to the hardware system where your thread or process being executed. So of course, like you can imagine, if you are asking for an address which is associated to the local memory, your access is faster. But if it goes beyond your local memory and you are accessing over the network into another machine's memory, it's going to be a little slower. It has a network latency and all this stuff available. That's okay. But the point is, your program now is not limited to the main memory of the system where it is being running. It can actually see or access memory of the whole network, whole cluster system. And that's what the NUMA is. And where is this non-uniform memory access comes from? As I said, if it is your local memory on the local system, it is faster. And if it is in a remote memory, it becomes slower. So there you go, is non-uniformity. Okay. Whereas uniform memory access, where it actually your process is bound to the local machine, all the memory access is same speed because you are accessing just the local machine. So that's your UMA organization, or which is cluster organization in terms what we discussed in earlier section. So NUMA motivation is that, like this is like a SMP, symmetric multiprocess system, cannot expanded without a limit. Like as we explained that it is limited to the physical processor socket available onto the machine. But a cluster system can. A cluster system, you just keep on adding switch, keep on adding machines to the switch, and we're done. Now, for a cluster system, application does not see a large global memory. It's bound to the local machine's memory, but a SMP can, because in a SMP concept, you have multiple processors connected, but through some bus sharing or cache crossbar or those kind of thing, it basically connected to the huge memory, which is sitting on that machine, right? Now, NUMA is a hybrid of these two things. As I say, like it's basically enjoys this expansion and extension like a cluster system. You can throw in different machines, connect different machines, add more switches, add more machines. You are infinitely scalable there. Whereas, like an SMP, it also sees a large global memory. Its memory access is not confined to one machine now. It's basically it can access anywhere in the whole system, like SMP does.